In this video, I want to talk briefly about finding the domain of a function. And specifically, I want to talk about finding the domain of the square root function, and then we're going to talk a little bit about finding the domain of a rational function. Okay? So, um, for the square, let's start by looking at the square root function. So here we have the function v of x is equal to the square root of x minus 1. Okay, so if you think about this, the only real restrictions we have here is whatever is underneath the square root has to be greater than or equal to 0, because for real valued functions, the square root um, uh, is not defined for anything less than 0. Okay, so if you have a negative number, square root of negative 1, that wouldn't give you a real value in the end. So everything underneath the square root has to be greater than 1. So anytime you see a function with a square root sign, okay, anything underneath that square root sign has to be greater than or equal to 0. Okay, so in order to solve this, it's actually really simple. We just set everything underneath the square root. We just solve the inequality. I'll just show you. Okay, we have the x is greater than or equal to 0. Okay, and we would just solve that inequality, and we would write our answer in interval notation. Okay, so in this case, it's basically already solved for us. We have all values of x greater than or equal to 0. Okay, so we would write this as the interval from 0 to infinity, where we include the point 0, because we can have this the square root of 0. That does make sense. Okay, so this one was quite easy. What about this one where we have p of x is equal to the square root of x plus 6? Okay, so we need to figure out for which values this function makes sense. Okay, so here we have the square root of x plus 6, and we need to make sure everything underneath the square root sign is greater than or equal to 0. So we'll set x plus 6 greater than or equal to 0. Now we can take 6 away from both sides. All right, and we'll have x greater than or equal to negative 6. Okay, and we can express this in interval notation as the interval from negative 6 to infinity, where we include the point negative 6. I want to do one more example here. Let's do g of x is equal to the square root of negative x, I don't know, minus 4. Okay, we'll do that. Plus 2. Why not? Okay, so in this case, again, we have to make sure everything underneath the square root sign is greater than or equal to 0. So like the previous two examples, we'll set negative x minus 4 greater than or equal to 0. Now, one thing you need to note, anything outside of the square root sign is irrelevant to the domain, at least for what we're doing now. Okay, it is not going to play any role when figuring out the domain. Okay, because that doesn't change. It's not going to affect anything to do with the domain. So we can ignore anything outside of the square root sign in these examples. So here, all we have to do is solve for this inequality. Add 4 to both sides. Okay, and now we have negative x is greater than or equal to 4. Can divide both sides by negative 1, but now we have to flip our inequality, and we'll get x is less than or equal to negative 4. So here we would have the interval from negative infinity to negative 4, where we would include point negative 4. Okay, so there's a little bit on how you would find the domain of a square root function. And again, just to reiterate, the domain is really just all of the values that make sense for the function that we're given. Okay, if there's anything you take away from the domain, that's it. Sometimes we can define domains to be restricted to specific values, more or less because we say they are. But in this class and in this situation, we just think of it as all of the values that make sense for the function. Anything you could plug into the function and the output would make sense. So having said that, let's take a look at f of x equals x plus 9 over x squared plus 15x plus 54. Okay, so when dealing with finding the domain of rational functions, you're going to treat this exactly like you did when you were trying to find the excluded values in previous problems that we've done. okay? It's just now we're going to express this in interval notation. We're going to, instead of writing the excluded values, we're going to write everything that's not the excluded values, okay? And I'll show you how to do that here in just a second. So the first thing we should do is probably factor the denominator here. So we have x plus 9 over something. And that something, we need to find two numbers that multiply together to give us 54 and add together to give us 15. And I'm thinking 6 and 9. So we'll do x plus 6 times x plus 9. We get that because 6 plus 9 is 15. 6 times 9 is 54. So there we go. Now, one thing I will say, you need to resist the urge to go ahead and cancel these x plus 9s here. And the reason for this is we really can't ever have a time where the denominator is equal to 0, okay? So as far as determining the domain of the function, we need to go ahead and determine any excluded values before we do any canceling. If you needed to do any more with this later on, you certainly could cancel. But when determining the domain, you leave it as unsimplified as you can get away with, basically. Okay, so you wouldn't cancel out the x plus 9s. So we need to figure out whenever the denominator is equal to 0 to figure out what the excluded values are. So if either x plus 6 or x plus 9 is equal to 0, the denominator will be equal to 0. So we will set each of these equal to 0. So if x plus 6 equals 0, we have x plus 9 equals 0. Okay, we can take 6 away. We'll have x is equal to negative 6. And we'll end up with x equals negative 9 as our excluded values. Okay, but if we want to find the domain, we want to find every value that is not the excluded values. Okay, so how would we do that? So think of it in interval notation. We want to include every single number on the number line except for these values. So to do this, we can write it as follows. We can write the interval from negative infinity to negative 9, okay? And we're not going to include the point negative 9, so we're going to use a parentheses here. Okay, and then we're going to union this with the interval from negative 9 to negative 6. And again, we're not including the point negative 9 or negative 6, but we're having every value in between those two. And then we're going to union that with negative 6 to infinity. And again, here we're not including the point negative 6. Okay, so what this is really just a fancy way of saying all of the real numbers minus negative 9 or negative 6. Now, if you want to get really fancy with this, okay, another thing you could write on a test, this is fine with me. We have a symbol for the real numbers we sometimes use. It's kind of like a fancy looking R. I write it like this. And you could just do the real numbers minus the set negative 9 and negative 6. That is fine as well. But if I were you, I would get familiar with the interval notation because your homework is going to ask you to do it in interval notation. Okay. Another way we can also use the set notation for the minus sign, which is like a backward slash here, negative 9, negative 6. Either way is fine. Any of these ways are fine on a test or in any written assignment you would have, because these all mean the same thing. However, like I said, your homework is going to ask you, any quizzes are going to ask you to do it in the interval notation here. Okay, so again, all you're doing is you're finding the excluded values and then you're writing everything on the number line that makes sense except for those excluded values. Okay, how about this one? Here we have a of x is equal to x squared over x minus 2. Okay, so here the numerator is fine. There's nothing we have to worry about here. But in the denominator, we have x minus 2. So the denominator cannot be equal to 0. So we'll just set x minus 2 equal to 0 to figure out when it is. So we'll add 2 to both sides, and we'll get x equals 2 as an excluded value, okay? And therefore, we're going to do the same thing we did previously. We're going to include every point on the number line except for the point 2. All right, so we can write this as the interval from negative infinity to 2, where we're not including the point 2. And we're going to union that with the interval from 2 to infinity. And again, we're not including the point 2. Or we can write this as the set of all real numbers minus the set just including 2. Yep. So either of these is a valid way to write this, but again, in your homework, it's going to ask you to do it in interval notation. So I would get comfortable with that.